I am going to document my project of building a 3-inch refractor. First, I picked up this lens from Surplus Shed. It's a Jager's lens, 83 millimeter, 3¼ inch, f/15, and it came with this nice little book, how to measure everything out, what the distances are for the baffles. I think this whole thing cost me $38 on one of their sales. Jager's is out of business. The company burned down in the early 80s. They were very popular in the 60s and 70s for making various sizes lenses for homemade projects. They sold the lens cell, all that stuff. And none of that's available anymore. I was fortunate enough to pick this one up from Surplus Shed. They were closing out their leftover stock, but that's all gone now too. So, and since I can't get a lens cell, I'll have to be creative and make something with that too. My first problem was finding a suitable tube. The project requires a 3¼ inch aluminum tube, 43 inches long. And I thought about using this piece of dryer exhaust, but there's just so many ripples and stuff, it would never really be very good. And plus, where the seam met makes a long flat along the whole length, which is very undesirable. I settled on a cardboard tube using a 36 inch and a 24 inch that I had laying around. And I'll use this section of that galvanized pipe to join the two. And then once that is done, I will surround the whole thing in fiberglass, which would provide enough stiffness, because the tube, even though it's slightly smaller than I'd like, it's suitable with a 3-inch inside diameter, but it's far too thin to make a decent or usable telescope. And since this is an f/15, it will be quite long. So this is my plan, to fiberglass the whole thing once the two halves are assembled. Here you can see I have fiberglassed the paper tube. It was a lot easier than I thought it would be. I had taped one side of the fiberglass sheet to the whole length of the tube, and then just rolled it as I was brushing on the fiberglass resin. And I worked outside on a piece of sheetrock, and after I was done, I just threw it all away, because once this stuff hardens, there's no cleaning it up, and it's quite hard. Next step will be I will trim off the ends, then I will mix up a batch of the resin and thin it with acetone and pour it inside here to get the inside cardboard, have that soak up some of this resin, so that'll make it hard through and through. It's already quite hard, probably good enough, but I'll just take the extra step and do the inside. All right. Here is the trimmed and primed tube. I did polyurethane resin the inside, let it dry, sanded the heck out of it, and this stuff is hard. Some spots I had to use a metal file, especially where the last piece ended. Left a big ridge. Only a file would take that off. Then a lot of sanding. And a word about sandpaper. I tried some cheaper stuff and it didn't work at all. This stuff is great. 3M Pro Grade Precision. I used 1/5 of a sheet. And they're still usable. The one sheet that I used. And I also wet sanded with this. It's got a rubberized backing. This stuff is wonderful. Not like some of the Chinese crap that I bought that basically looks like beach sand glued to paper. So there are some imperfections I expected. You can see. And the primer helps show that up. What I will do is use some of this fiberglass gel resin, mix it up and putty in the imperfect spots, the holes, the pits, whatever. Let it dry, sand again, prime once more, and then the final coating will be this Rust-Oleum appliance epoxy. This stuff is super hard, very shiny. Only thing is it takes a long time to dry between coats, like a whole day. So it is a not a quick thing, but I've got plenty of time, so that's what I'm planning. I've started working on the lens cell and the baffles. These are cut out of a sheet of aluminum and then a piece of plywood, and this will be glued, painted flat black, shoved down the tube to the correct distance, and glued in place. I made 2 of them. I found a website that gave me the correct size and distance. So I had to change the size because a 2.5-inch hole would have made this just way too thin to cut. So this is a 2.25-inch hole. So that changes the distance. And that website gave the formula for doing that. I also cut out these 3 pieces of hardwood and the aluminum discs. The same piece. This was a little bit of work. I did it on the drill press with one of these hole bits, but it's impossible to try to cut that out of a piece of hardwood. This is a piece of a drawer front from Salvage Furniture. It's 7/8 inch thick oak or some very hard wood. And I tried cutting through and it just does not work. So what I did is I put it on a radial arm saw and cut all the way around as close as I could to the hole. Then clamped it, screwed this onto here, clamped it in my drill press, and was just able to shave the rest of it off. And it made a nice edge to this. And there's my little bench drill press. So I paid $30 for that at a truck sale. Made in China, of course, but it's sufficient for a home tool. Now what I will have to do next, I already drilled the pilot holes. Now I put all these, before I did that, I put all these together, put a screw through it, put them on my drill, and then spun it on a piece of sandpaper and got it all nice and smooth. this piece, there will be an inner hole, and the lens will drop in. These two pieces will have a slightly smaller hole, giving it about 1/8 of an inch lip on the front and the back, holding the lens in place. These 3 holes that I drove through every piece all at once will be the 3-point pivot that will hold this onto the holder. This piece will also have a hole in it, and it will be glued to the end about here, and that will be permanent. And then there will be 3 screws sticking up. Well, you will just slide this. I will just slide that in place and have some adjustment screws so I can pivot the lens and get it right. I'm a little worried about cutting the inside holes because the outside was so difficult, but this is what I use to cut these, and it's quite a good machine tool bit. And the smaller holes are easier because you just don't have this distance and the flex that it incurs and the wobble. I actually had to hold the drill press with one hand and crank it down with the other because it was wobbling so much. So I'm thinking that I should be able to go half through, turn it around, and go the other halfway. It's a much thinner cut than this one, and it worked okay here. So that's the plan. I will continue this later. I made some progress. The lens cell is nearly complete. You see the holes drilled in the center, and the 3-point pivot screws sunk into the wood. This is the part that gets glued to the tube, and here is the part that holds the lens in between these 2 lips of the aluminum plate here. And I will have an O-ring, since the lens will not totally make it up here tightly. There's a little gap, but that's good, so that can be held in place by the O-ring. So also what I've been working on is the focuser. I cut 4 discs. This one is smaller. This goes into the tube. Well, it will. It's snug. And I will drill the same way I did these. I gathered some hardware. I had this focusing tube that I made. That will go inside. Once I drill holes. Then I need to figure out a way to get this gear and bushings so it can travel in and out. And since I don't have any bearings, this will be a very basic focuser. I have this very thick Teflon adhesive. I will line the inside of the tube, and this should slide in and out fairly easily. I don't have a rack gear, so I'll have a strip of this, and this gear will actually carve teeth and be able to move this in and out. So that's the plan. see how well it works. Next step is to cut holes. Well, first I want to drill 3 points around here and put these screws through to hold it all together. 3 long screws. So I'll put this on the drill press and go from there. Here you can see the lens cell mounted onto the tube, and I have the, I don't know if you can see it, the lens is installed. The focuser came out really well. I drilled many test holes to get the inside diameter correct, and I ended up using a rack gear after all, and I brazed it. I don't know if you can see the solder. I brazed it onto the tube, lined it with Teflon like I said I was going to, and cut a slice out of one of them and put a pinion gear in, and it is butter smooth. I'm really happy with how this came out, and there's very little wobble at full extension. Only thing, a store-bought one would have a lot more travel. This is about 3 inches of travel. Most of them will probably have about 6. So I'll probably have to trim the tube so that focus comes about 1 inch away, somewhere in the sweet spot, using different lenses. Make sure that it comes to focus. I left the tube about 2 inches longer than the instructions called for so that I can trim it. Better to leave it longer, and it's easy enough to cut. And if I made it too short to begin with, then all this would have been for nothing. Alright, next step. I've assembled all the pieces, and I have a completed optical tube. I recently made this little finder scope bracket. In and out. The focus travel works well. I had to trim about 5 inches off the length to get it to come to focus, but the baffles are installed. Only thing left to do is to adjust these 3 points for the lens, and I will use that either with an artificial star indoor, or I'll do it outside with a real star. Okay, next step is to build a cradle. And I've cut out the parts for the tube cradle and the actual mount. Everything is drilled, cut, sanded, ready to be glued, screwed, and clamped, and then of course varnished, and we'll see how it comes out. I used the same Teflon for the bearing surfaces that I used on the focusing tube. Okay, next step. And here is the completed telescope on the tripod. I made that tripod a few years ago. You can see the mount works quite well. very smooth. And it's all here, everything you need, and it's aligned. It's all ready to go. It's quite long. You can see an f/15 3-inch is a pretty long telescope. That's why there probably weren't so many of them. Imagine with a 4-inch, it would be over 6 feet long. That's why the f/11s, f/8s became much more popular. They're much easier to handle. But I'm quite satisfied with how this came out. This knob here, I can adjust the tension. And if I want to snug it down up here, I have to use the Allen keys that basically are holding all this stuff together. So the whole project came in under $60. I didn't have to buy a whole lot. The lumber, I had all that. The hardware, I had it. Mainly it was just the lens and some paint. And that's about it. So thanks for watching my video.